Today here on the bench an ICOM IC-7100, and this radio will not transmit. So let's have a look what's going on here. Welcome to TRX Bench. Okay, and let's right go into the video. So I've already connected power supply to the radio, and I've already connected my communication tester to the antenna input. So let's fire it up and see what's going on. And yes, it is firing up, no problem. And as you can hear, we have received, but that was not the complaint. The complaint is that it really will not transmit. So let's see. So I've set the radio to FM because then we have a constant carrier, so that is sometimes a bit easier to check. Okay, and let's see that we can have both the radio display and of course our LP500, and yeah, let's simply press PTT and let's see. Okay, so you can see radio switching from RX to TX, so you see it here on our red LED, but it seems that the radio only puts out 200 milliwatt, which is really not a lot. So let us see where we have our RF power set to, and yeah, it is set to 100%, and that means it is just fine. So that is definitely not the problem. So we really obviously have here a problem with our output power. So let me reconnect my tester, and let's see what that means. Okay, as we have seen such a low output level, we can easily connect it here to the tester, and we can transmit into it, and I want to verify the value what we have seen, and that is what we are doing. So you see 215 milliwatt, and more interesting for us is as well that here our TX frequency is at 14190. So that means that obviously output frequency is just fine, and we really have only 200 milliwatt. So now I'm interested if we go to let me see, to 2 meter, and let me dial in here the frequency which we have dialed in our radio, and of course I have to use the other antenna port. So now it is in, and you already hear our tone. Very nice, and power is set to 100%, so everything is good. Let's see what we have on 2 meter. Okay, so 300 milliwatt, so that is not much more, but obviously here our transmitter is working just fine. So, and now it is getting interesting, because shortwave and our VHF and UHF are different power amplifiers. So that means that both amplifiers, power amplifiers, has to be blown if we really don't see an output signal or output power on VHF and on shortwave. But I do not believe that both output power transistors are blown, so it seems that the problem must be somewhere else. So maybe there is something wrong with our driver stage, which we need to check. But first of all, I just want to go into the 70 centimeter band, and let me check for 33, and yeah, I have received, as you can hear. And of course we do here our same test. Power is on 100%, and we have 116 milliwatt, but the transmit frequency is just fine. Okay, so that is already telling us a lot. So let's have a look into our block diagram to understand what I'm talking about. Alright, and here it is. So first of all, we can see that we have our shortwave 50 megahertz and 70 megahertz antenna here, right? And on the other hand, we have, maybe I zoom it a bit more in, that it is easier for you to see. So once again, this is our HF antenna, right? And down here we have our 2 meter and 70 centimeter antenna. Okay, so if we go now back, we see that we have a power amplifier for our 2 meter and 70 centimeter band, and we have here a power amplifier for shortwave and 50 megahertz, right? So, and I really don't think that both power amplifiers are blown. So that is very, very seldom that really everything is gone in radio. So if it comes to a power amplifier, normally we would have the one side or the other, so that means HF or 2 meter 70 centimeter, but both is very seldom. So we need to go back a little bit, and we find here a duplexer which is splitting our signal for our HF power amplifier or our VHF UHF amplifier, right? And we have here our driver, and you know, that is really the point where I would like to start probing, because does our driver really works or not? So that is now the interesting question, and therefore let us crack the radio open and let's see what's going on here. Okay, and we are in, and we have all what we need to probe for the first step here on this side. So what you can see here, we have here our both broadband transformers, so that is for HF 50 megahertz and 70 megahertz, and this both here is the power amplifier. And we have up there our both antenna connectors. So in the moment it is connected here to HF, and this here is then of course VHF and UHF, right? Now, as we have seen in our block diagram, we have for both passes we have the same driver, and the driver transistor is this guy here, and then we have, so that is the driver, then we have a pre-driver and a pre-driver, and then here we have our input coming at least from our main board. So yeah, main board, PLL and whatever hangs together to get here our transmit frequency right here onto our power amplifier board. So it might be a good idea. I mean, yeah, there are always different ways to go through. So you can start and of course can test your DC levels if everything is fine. But on the other hand, we can start here and simply check if the level coming here from the main board right into our PA board is present. So that is an easy step, because we can undo it here very easy, this little coax cable, so no problem whatsoever. I think that might be a good starting point. What I haven't said so far, I said, of course, this is our HF, and underneath, so where you see this both screws, and underneath we have here our VHF and UHF amplifier, which go then here into this part here, right until here to our antenna connector. Yeah, that is everything together, and as I said, let's start here with a very easy thing. Let's check if we have level right here. Okay, as you see, I've here connected to my level meter right here to the output from the main board, of course, and yeah, let's read our level. And well, we do not have any informations here on our schematic, but these levels are usually around 0, -10, -15 dBm, so depends a little bit on the design. So yeah, something between 0 dBm and let me say -10 dBm would be a good level. Yeah, let's see what we can read. Okay, so let me press our PTT, and then we will see what we have. And wow, so -36 means, yeah, that is really funny. I mean, minus 36, or it is almost -37. Clearly tells us that this input level into our PA board is definitely too low. So with this drive level, it is clear that we are not able to really push our power amplifier to get our on VHF, I believe 50 watt out. So something seems to be wrong on our main board where we get this signal from. But to be sure that our assumption is right, we simply apply our minus, let me say -20. We start with -20 dBm, and then we increase the input level, and let's see what our output power will be. So we use our frequency generator, right, and we just inject our 145 something megahertz here into our PA board, and then let's see what finally the output power will be if we crank our generator up to a level, let me say around minus 10 dBm. Let's see how it works out, and then we know if our power amplifier or our power amplifier board entirely is working or not. Okay, so what you can see here, I've already prepared here the generator just to be able to inject the frequency right into our PA board. Okay, so you can see it here right on the board. So now I'm going to feed in my signal here right from our generator as discussed, and I start off with, as I said, minus 30 dBm. So let's go up here to our meter that we can see it. Alright, so I'm switching on my generator. It is now switched on, and now with minus 30 dBm, let me press here our PTT, and you see we have 891, and frequency is obviously right, so very nice. Now let me see. Okay, now as discussed, let me increase here our generator level, and yeah, you already see, let me double check that you can see it. Yeah, so you already see that we are able to get our output power up. Our output frequency is obviously right, and now I am, yeah, that is 10 dBm, 52 watt. So let me go down here that you can see minus 10 dBm. Okay, now let's go back here, and you see 53.7 watt, 145 290 megahertz. So that is definitely telling us that our power amplifier is obviously working just fine. So that means something is wrong on the main board, and yeah, that is what we need to investigate a little bit more in depth right now. Okay, so we are now here on the main board, and we see here, so that is our little coax cable, which should supply our minus 10 dBm to get full output power. And yeah, I've again connected my level meter to the output, but first that we know where we are, let's have a look here in our block diagram. Well, and of course we start where we, yeah, let me call it where we lost our signal. And you see here, let me enlarge it a little bit, then it might be easier for you. So we see here that is RF, which means this here is from the main board, the output to our PA board. And yeah, let me go back here for a second. This is our PA board, and we have seen it before. You see here's our input, and we know when we put in here minus 10 dBm, everything is just fine. Then our power amplifier will work, and we get our wanted, yeah, in our case we have tested it on 2 meter, our 50 watt or so. Now when we go here now on the main board, right, we have here now of course the output, as I said, and if we follow back here, we find here our IC-3021, which is our, yeah, let me call it last amplifier on the main board. So this here should supply at least our minus 10 dBm to be able to drive our power amplifier. Okay, so far so good. Now again I have connected my level meter, and yeah, let me go over. Yeah, and when I now transmit, you see we have our minus 30 dBm, and you see that it is varying a little bit. So it is not constant minus 30, so we have seen it lower, minus 30, what was it, 35 or 36. So it seems to vary a little bit. So anyways, we know that this minus 30 is too low. Well, and back here on the board, we find here this guy here. This is our IC-3021, which we have seen in the schematic. And that is really, again, a very, very tiny little guy. And what we want to check is first input level, and then, of course, we want to check output level to see if this little guy here is working fine. Okay, and we check it with our spectrum analyzer. So we have dialed in 21.2 megahertz, and that is what our analyzer is dialed in as well. And I'm now at the input of our monolithic amplifier here. And yeah, let me see that I get a good connection, and let me press the PTT. And here is the PTT, and we have minus 19 dBm right at the input of our little IC. And now let's go to the output, and let's see what we can test there. Okay, so now I've connected it to the output, and now let's press PTT. And yeah, okay, so we are testing at the output minus 35. So that is what we have seen before, and you see the output of this amplifier is weaker than what we have at the input. So it is 15 dB under our input level. So minus 20 is our input level, and our output level is minus 35. So it is not an amplifier. So what we have in here is an attenuator, right? Alright, and this is our schematic. So you see here the output to our power amplifier board, and that is our main unit, of course. So let me enlarge it a little bit, and well, here is our IC-3021. Let me do it a little bit more, and okay, so you see input where we tested minus 20 dBm, and here is our output, and there we tested minus 35, which means this guy is attenuating, it is not amplifying. Alright, what I've done, I have tested here our supply voltage, and supply voltage on pin 1 and at pin 3 is given, so it is something around 3.5 volt. I mean, it looks a little bit low, but I mean, maybe that is an indication for that something is wrong. because our supply voltage should be 5 volt, as we can see here. This is only 100 ohm, and our amplifier itself does not take so much or does not consume so much power. So therefore, if we are testing here at 1 and 3, I believe it was around 3.6 volt. So that means it might be already an indication that something is wrong. But in any case, our power supply, or our supply voltage, so that is the right way to say it, is definitely just fine. So now we need to see what our amplification will be. So this is, as far as I know, a monolithic amplifier, and it is matching for 50 ohm. And yeah, now we need to know what is the gain. So is it enough if we supply minus 20 dBm to get here at the output minus 10 dBm? I mean, we have seen that we need minimum minus 10 dBm. Our input is minus 20 dBm. So this IC should be able to amplify at least 10 dBm. So let's have a look into our data sheet. So this is a BGA 2709, and let's see what the data sheet is telling us. And here it is, BGA 2709, MIG wideband amplifier. So that is what we have, and yeah, you already see it is right what my assumption was. So it is internally matched to 50 ohm, and yeah, that is really the killer figure, let me call it, because that is our gain. And the datasheet is telling us that the gain is 23 dB. That means when we feed in minus 20 dB, so we should see at the output plus 3 dBm, right? But let me go down here. Yeah, DC supply should be typically 5 volt. We are testing a little lower, so that's what I meant. Maybe that is already an indication. And let me go ahead, and yeah, I think that is once again the important figures. So the insertion power gain at 100 megahertz should be typically 22. So if we simply calculate with 20, that means if our input is definitely minus 20 dBm, we should see at the output minimum 0 dBm, and that would then the right amplification. And what we see is only minus 30 or minus 35, and that yeah, brings me to the conclusion that we really have here a faulty amplifier, a faulty BGA 2709. Okay, just that you see what we have. Let me go down to our pin, which I'm down at that pin. Let me see what the output voltage, not the output voltage, the supply voltage will be. So we need to press, of course, our PTT. And something is wrong. Yeah, good idea is if I connect ground, that would be a very good idea. And now once again, and here we are. So we are testing for 3.3 volt, and we have seen it should work on 5 volt. So we only have 100 ohm in between. Yeah, as I said, that might be already an indication that this little mic is blown. Okay, so everything is prepared to swap our IC out. So down here we have it, and of course I have received, can you see it? Yeah, so I have received here the new one. So we gonna swap this new IC here into a radio and see if it will work then. Okay, this is really a little bit critical, as here our coil is not heat resistant, so I've tested it here. So that means I cannot go here with our tweezers down to our component. It is cold, the tweezer is cold, yeah? So can't do anything to it here. So I cannot go down really with the tweezer. That would also really jeopardize here our coil. So maybe, yeah, I try start with hot air, but maybe I have to take off here our coil, simply not to damage it. Yeah, let's see. Okay, so let's put here a little flux here down to the component, just to get it off a little bit easier. Yeah, but as I said, we really have to be very, very carefully. So I'm not really feeling too confident that I'm able to get it out without damaging the coil. But well, let's see what we can do here. Okay, lucky enough to get it out. And yeah, now we have to clean here the PCB, and you see the coil is still fine, and all the other components are where they should be, so no problem. So our pads are there. Well, quite happy to have this outcome here. Okay, pads are cleaned, and I have removed the solder, and now we have to clean it with some alcohol here. And well, looks quite nice. I guess we can easily install here our new IC. Oh, quite nice. And now let's dry it out here with some air. Yeah, and I'm going to correct here the placement of this diode, as it looked like that it was moved a little bit by the hot air. So I have taken out this diode and will place it new, so that we can sure that you know, it is fitting as it should. Alright, and I have sitting here the little diode just here, and we really have to make sure that the orientation is right. And so that side seems to be the cathode. I mean, it is not so clear as we would have a clear white line, but you see there is gray zone, let me call it that way, and you see here that diode we have the same, and according to our service manual, it has to go in exactly in the right way. So I have to turn it like so, and then we have to move it here to our position, and that is always fun. And you see that it is now sticking here to our tweezers, and that is something what happens always, and you know, that makes it not easier. So you really have to work with two tweezers, like you can see it here, right? Just to get it here to the right place. And then yeah, we have now to solder it down here. Alright, and I have tacked it down only here on one solder joint, and I really wanted to make sure that it is in the right direction, because have a look right now. So to be honest, I'm not sure which side is which, right? Because you see it here and you see it there. So I know that so this is a diode which is still in without any problems. And let me go down here, and you see the red one here. My red probe is on the anode, and let me go with the black one to the cathode, and the voltage drop is 0.7 volt. So that tells me that is how it should. And now I do here exactly the same test. And you do not hear it beeping. And I really show this because that is something what easily happens. So it looks like that I mixed up the orientation. So I've now swapped here my probes. So now I put here my red one, which is plus, which should be anode, to exactly the opposite side, and yeah, and now I have the voltage drop this way. And that shows that it is really easy to mix the orientation up. And that is what has happened here. So I have to do it once again. It is simply in the wrong way, and I have to change the direction. And so I can't say it often enough. That is something what you know happens very often, especially to unexperienced technicians. As you really think everything is just fine, and you put in everything you want to try and check out your circuit, and then you see it doesn't work. And it is not because one of the components is still dead or whatever. It is simply because you was not able to really see the direction. And even let me see if I here tilted a little bit, but even then I'm really not able to clearly say what is really the direction. I mean, you've seen it when we have here the diode laying at the side. We were quite sure, but now I really have to admit I don't know where is our indication line for cathode. I can't tell, right? So that is really crucial. Always, really always have an eye on that. So now for me, I go down and swap it around, flip it around so that it is simply in the right direction. Okay, so I have flipped it simply to the other side, and once again let's do it the right way. So this side should be anode, this should be cathode, and let's see, and now it is right. And not directly soldering it in on both sides makes it really much easier to me to correct my mistake. So yeah, that is always very important. Can't really tell it enough. And just want to show it here to you on the screen. So that is our board layout, and you see here both diodes, and you clearly see here that this is both the cathode side, right? And so you always have to check it. And the next what we have to check out is here the orientation of our IC, and you see that we have here our dot, and of course we need to put our dot here in this corner. So that is the next what we really have to have on mind. Alright, so our new IC is simply lying here on the board, and I hope you can see that our dot here is here, and we have here a dot as well, but it is always clever to compare it with your service manual, and both are telling us the same. And of course we know from our old IC that it was in the same direction, and now again it is sticking here to the tweezers, and I try to simply get it down here to the board, and you see that is how it looks like. And now of course we need to solder it in. Okay, and if you wonder how I solder IC like this in, I do it really conventionally, as you know, that is the easiest way with ICs like this. So you see, I put down here a little solder on the solder point, and then, you know, I try to bring it here in position, and when the IC is in the right position, more or less, I just try to tuck it here, right, at this pin, and if it is tucked down, so that means it cannot move anymore, then I really can go step by step like a normal IC. I mean, of course, I'm working here under a microscope, as this IC is really that small that I really can't do it beer eyes. I mean, if you are 20 or maybe 30, then your eyes might be nice enough to do it without magnification. For me, no way. So I do it under magnification here, under a microscope. And yeah, I go now step by step. And you are right. We have to do this solder point as well, because this diode is only tagged, and we do it now with together with our IC, and then it should be fine. Alright, everything is back in, and we can go ahead with testing. Alright, and everything is now connected so that we can test it. So power supply is connected, our operator panel is connected, and of course our radio itself. So let's see, and of course here our LP500 is connected as well. So let's see what happens if we fire it up. I mean, that was never the problem. So it is firing up. I mean, of course, still a good sign. It is still on FM, so that is where we tested it with. And we have seen when we did our first test that we only have, I don't know, 200 milliwatt or so. So radio was not able to produce output power. And we went through all the steps, and yeah, we found our little mic, which was faulty, and that is what we have swapped out. And now let's see what happens if we try to transmit. So let me do it here this way. Yeah, I think we can we see everything here? Yeah, I guess yes. So we see our LP 500, which is for the moment in time the most important test set. Let's see what's going on. Hey, so radio is obviously back to life. Not sure if you was able to really see it here on the display. So I zoom it in a little bit for you, and let me see. Alright, so, and you see it is really back to work. And okay, it is still on FM, so let's see if we set it to SSB, just to see if everything is fine with SSB as well. So let's see. 1 2 1 2 1 2. Hola, 1 2. Test test test. Audio. Yeah, and you see that is working as well. Just for verification, let me go to the 20 meter band, because that is the frequency where we did our first test, and it is also still on FM, and we should see exactly the same. And yes, we see our power is back. So that means our repair is done. Our radio is back working, so it was really this little monolithic power amplifier, so the last stage on our main board. And yeah, I do not have a clue why it was blown, but you see, sometimes it is a little bit a mysterium, I don't know. But anyways, it is fixed, and I really don't want to drag this video out too much. Of course, I have to do some additional tests when I put it together now. but it is fixed. I do some tests. Maybe I need to do an adjustment here and there, but I don't think so, because it was not a repair on our power amplifier unit. It was really nothing special. I mean, right from you know, power amplification and such. So that means let me stop it here, and thank you for watching, and if you like it, please give me a big thumb up, because that always helps. And as always, catch you next time. Bye!